And yep, I am live. Right. Now let us begin. And today might just be the last assembly stream that I'm doing. Well, in this series, that is. And I have some other plans after this, but today might be it. This might be the last assembly stream. We are on the last chapter, and that is just crazy that I reached this far. Absolutely crazy. And in just a month, that is in just 27 streams, here I am at the end of the book. Even though I did not, I haven't understood completely the things after in the middle half, but I have gotten a very good idea about what those things are, and I would say even better idea than an overall idea, and I can always come back to them when I actually need them. And for now, here we are. But in the first half, I have done absolutely amazingly. I have written a lot of assembly programs, and this has been quite a fun stream. And maybe at the end, I will do an advent of code question in assembly. If I get some time at the end, I might do it. So stick around. Shit, clickbait. Yeah. Running without an operating system. The previous chapters assumed we did quite a bit. Yes, we were reading about exception processing, AArch64 execution, and there are exception states. There is EL0, EL1, EL2, EL3 exception state, exception level, and the applications run at exception level 0. Kernel runs at exception level 1. It has higher privilege than EL2, and EL3 is the level with more privilege than the kernel, and at this level runs the virtual machine code. Not like virtual machine does not run on this level, but at this level there is a code called hypervisor, which allocates resources to a virtual machine and to the main kernel, so that the main kernel and the virtual machine both think that they have the whole device to themselves. So this hypervisor creates a sort of illusion for the base kernel and the guest kernel, and they think that they are the only ones on this machine, but they are not. There is a parasite in the mix. And then EL3, exception level 3, which has the highest security and all, not security, but has all the privileges and can do anything if some code is running at this level. And what happens at this level? Secure monitor manages security, like basically firmware and other things. The major difference between EL0 and high levels is that code executing in EL0 cannot access system registers. EL1 can access most system registers, EL2 has additional privileges, and EL3 has all privileges. The only way that the processor can change from one exception level to a higher is when an exception occurs. The only way that the processor can move to a lower exception level is by executing an exception return instruction. When changing the exception level, it is also possible to switch between AArch64 and AArch32 execution state. That is crazy. The way that I would change the exception level from a lower number to a higher number is by raising an exception from the lower number, and the only way that I can come down from a higher exception level is by returning an exception state. That is the exception which caused the exception level to rise. By returning that exception, I can come back down, right? When changing exception level, it is also possible. Yeah, and the only way the processor can move to a lower exception level is by executing an exception return instruction. Exception return instruction. When changing the exception level, it is also possible to change mode from AArch64 to AArch32, so that if an exception is raised and the exception handler code is not yet written in AArch64, the processor mode can change from AArch64 to AArch32 and handle the exception according to the old AArch32 code. That is, it is backward compatible. The processor also supports two security states, secure and non-secure. EL3 is meant to manage the security states, and EL2 is meant to provide virtual machine capabilities. In many situations, only EL0 and EL1 are required, and most processors may not provide EL2 and or EL3. May not provide. Okay. On power up and on reset, the processor enters the highest level exception available exception level. Yep. Okay. Each exception level has its own stack pointer, link register, and saved process state registers. It has its own stack pointer, link register, and saved process state register. Saved process state register. Table 12.1 shows the names of these banked registers. These these P state register. Oh, all of these exist in the P state register. These negative, zero, carry, and overflow are the four P state registers that we have learned about. But the P state register also has all of these other crazy things. Wow, TCO, DIT pan. Okay. The table 12.1 shows the names of these banked registers. When the exception level changes, the corresponding link register and stack pointer become active and replace the user stack pointer and link register. So physically there is only a single stack pointer and link register, but the contents of the stack pointer and link register are stored in the P state register for different exception levels, and when that exception level is entered, the current link register and stack pointer are stored in the P state, and the ones in the P state which represent the new exception level are brought out and put into the link register and the stack pointer. Also, when an exception occurs, the current P state register is copied into the SPSR stack pointer stack SPSR SPSR saved process state register. Saved process state register for the exception level that is being entered. When an exception occurs, the current P state is copied to uh, EPSR ELN, where N is the exception level being entered. The P state register is updated. Okay, the exception level stays the same or gets higher. The return address is stored in ELR. Is there any ELR in there? What the heck is ELR? ELN. The program counter is set to the appropriate vector address, not vector address. Okay, and if it is synchronous or S security error exception, ESR EL exception level N. Okay, that much I understand. Exception level N link register. Okay, LR is link register, I guess. Let me ask a friend of mine. What do I want to ask? When an exception is raised, then the link register and the stack, stack pointer for the current exception level is stored in the P state, and in the LR and SP are updated with the new values. Explain in detail the whole process of raising an exception. Raising an exception. Okay, when an exception is raised in ARM64, ARch64 processor, a well-defined sequence of actions occurs to handle the transform from the normal execution to exception handler. Let's go step by step to understand what happens. Okay, what is an exception? That is a very good question. An exception is when a lower privilege level, for example, a user tries to execute an instruction which it does not has any privilege to execute, then an exception is raised. An exception is an event that causes the processor to change execution from its normal program flow to specially defined exception handlers. Exceptions can occur due to interrupts. Interrupts are one type of exceptions. Okay, interrupts are when an external device tells the processor, here is what happened and do something with it. Update yourself. For example, a key press flow to special execution handlers. Interrupts. Example, hardware signals like timers or external interrupts. Hardware signals like timers or exception or external interrupts. Okay, like timers or exceptional external interrupts. Huh. Huh. Ah, ah. Is this what happens in asynchronous programming? And threads programming is different because we are expecting the other thread to return at a specific point in our main thread. But in asynchronous, we do not know when that will end. So is that interrupts? No, 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 no. It just puts it onto the call stack and the main thread executes it from there. Faults, example division by zero and invalid memory access. This can also cause an exception. Software requests, example system calls via supervisor call and debug events. Example breakpoints. When an exception occurs, the processor saves important registers so it can return to normal execution later, switches to the correct exception level. Okay, okay, that makes total sense. Starts executing the exception handler. When an exception is raised, the processor saves the current state of the registers somewhere so that it can come back to the normal control flow, changes, hires up the exception level, and starts executing the exception handler code. What happens when an exception is raised? When an exception occurs, the processor follows three main steps. Identify the exception level transition. To what limit do you want to go? Okay, the AArch64 architecture has four exception levels: E0, E1, E2, E3. Hyper for virtualization, hypervisor, somehow called hypervisor, not supervisor, because I guess kernel is the supervisor, but this is even above that, so hypervisor. The processor determines where to go based on the current exception level. Mhm. Based on the current exception level, the exception vector table, which contains address of exception handlers. So it before checking the exception handler, it before changing the exception level, it first gets the exception register, the exception it before changing the exception level, the processor first goes through the exception vector table, it seems. Okay, the exception syndrome register. ESR, exception syndrome register. Was this also there? Exception syndrome register. Exception LR. Okay, exception syndrome register. Exception level X, which records the cause of the exception. Okay, so we have a different register. For example, if a program running at EL0 user mode makes an syscall HVC instruction, the CPU will transit to EL1 kernel level mode so that the kernel can handle the supervisor level, the supervisor call, syscall. Step 2, save the previous execution context. The processor saves critical information about the interrupt process so that execution can resume later. This includes exception ELR, exception link register, stores the return address of the instruction that caused the exception and the next instruction to execute. Okay, like link register, exception link register, exception level X. Okay, and state process save process state register, saved program status register, saves the current P state, processor state including flags and execution, saved program status register. Okay, LR link register, updated with the new exception returned from this uh, and stack pointer. If the exception level changes, the stack pointer is switched to the appropriate exception level stack. Okay. What happens to link register and stack pointer? What I'm guessing before reading that, link register gets updated with with the value that is in the exception link register ELR, and the stack pointer SP. It gets updated to the top of the stack of the new exception level. The current values of ELR and SPSR ELR is stored so the execution can be resumed later. The LR and SR are updated based on the target execution level. Yeah. If moving from EL0 to EL1, SP will switch from the user stack to kernel stack. The current values of ELR, XLX are stored. Okay. Yeah. Yep. Change execution mode. The processor switches execution mode. Yes. After doing saving all the previous execution state, and this was step 2. Step 1 was identify the exception transition. Yep. After identifying the exception, it saves the state and then changes the execution mode, updates the P state register, disables interrupt if needed, okay, to prevent nested exceptions, okay, switches to the appropriate stack, example EL1 stack when moving from EL0. Locate the exception handler. Each exception level has a vector table that stores the entry address of handlers. The vector-based register, VBAR, vector-based address register. Exception level X points to the table. The processor calculates the correct handler address based on the exception type. Control jumps to the corresponding handler. For example, an EL0 exception level 0 program triggers a system call that the handle at this base address of the handle plus an offset is executed. What happens in the exception handler? Once inside the handler reads the register. Exception syndrome register, which contains the state to determine the cause. It may inspect memory using for fault address register if applicable. The handler executes the necessary operations, example, handling a system call, processing an interrupt. It prepares to return the previous context state, returns from an execution, stores p state from what I stored here, program counter from EL, yeah, jumps back to normal state, and before that stores the context as it was before. System call to EL from EL0 to EL1. First, I made a system call, triggers an exception. The CPU states the return address and the stack point status program state in the saved program status register, and then the CPU switches to EL1, loads the kernel stack pointer, finds the exception with uh, the vector bar address register and executes. The handler processes the system call and prepares for return. It gives back the context and then return makes the program counter go to the next instruction in the normal flow. Yeah, okay, that makes more sense. To return from an exception, the ERET instruction is executed. Exception return restores the p state from saved program state register exception level n and restores the program counter from exception link register exception level n. Software execution, my bad. Software execution in an exception level higher than EL0 can select whether to use the default stack pointer exception level pointer to or the stack pointer EL0 stack pointer by executing an MSR move stack register. This immediate one instruction. This allows privileged code to access and modify the user mode stack. This can give privileges to access and modify the user stack. For example, when an exception occurs, registers can be saved on the user mode stack. Registers can be saved on the user mode stack, then restored before going back to user mode. Okay, and all of that, yeah, quite a bit of stuff. Synchronous and asynchronous, and creating the vector tables, that is okay, but that is something handled by the operating system using the vector tables, confirming asynchronous exceptions. Okay, there are two types of exceptions, asynchronous and synchronous. Okay, synchronous exceptions are synchronized with the CPU clock. This type of exception includes data abort from memory management units, perform line failures for load, store operations, service call, and illegal instructions when the exception cause is by the program that is running. It is synchronous. Asynchronous exception may occur at any time and may not be synchronized with the CPU clock. These exceptions include interrupts, request IRQ or FIQs from external devices, or error, syntax error, system error, interrupts. Yeah, interrupts. Okay, and yeah, we can move past all of that. I do not want to see how vector tables are written and how they are managed. The boot process, that is going to be interesting. And also, I will have to read about this more about exceptions a bit more from different sources. Exceptions, that is crazy thing. Exception levels, okay, there are different levels at which the processor can work, and these levels are in the processor. Okay, the processor knows in which level it is, and these levels are encoded in the processor itself, that is in the hardware. That is, they are in the hardware, right? And when an exception is raised, then the processor sees to which exception level uh, and the processor sees that which exception level will handle the exception, and it stores the context flow current context for the normal flow at some place, and then changes the exception level at the higher exception level to the higher exception level, and pulls in the exception handler from that specific exception level's vector table and starts executing the exception handler. And after the exception handler has done executing, the exception level is lowered, not lowered, but first the context of the normal flow is brought back, and then the exception level is lowered, and also the program counter is also updated to point to the next instruction in the normal flow. Okay, now the boot process, and then we also have something called the main program using an interrupt. Interrupt is crazy, and timers, exception handlers, the ARM processor profiles, and that is done. About three topics, and then we will do advent of code in assembly, which is going to be crazy. Yo, boot process. The boot process. In order to create a bare metal program, we must understand the processor does. We must understand the processor does when we must understand what the processor does when power is first applied or after a reset. The ARM CPU begins to execute code at predetermined address, which depends on the configuration of the CPU. The ARM CPU begins to execute code at a predetermined address, which depends on the configuration of the CPU. In order for the system to work, the startup code must be at correct address when the system starts up. Yes, yes, yes. When I supply in power to my machine, then the ARM CPU starts executing code from a predetermined address. Yes, and that address has to be correct for my machine to work. On Raspberry Pi, when power is first applied, the ARM CPU is disabled and the graphics processor unit is enabled. The GPU runs a program that is stored in flash memory or ROM. That program, called the first stage bootloader, reads the second stage bootloader from a file named bootcode.bin on the SD card. That program enables the SD-RAM and loads the third stage bootloader. That program enables the SD-RAM static or dynamic. What the heck is this? SD, static or dynamic, and then loads the third stage bootloader start.elf. At this point, some basic hardware configuration is performed, and then the kernel is loaded to address this from kernel 18.emg on the SD card. Once the kernel image file is loaded, a this instruction is placed at address 0 and the ARM CPU is enabled. The ARM CPU executes the branch instruction at address 0, which immediately jumps to kernel code at this branch to this. To run a bare metal program on Raspberry Pi, it is only necessary to build an executable image, or it is only necessary to build an executable image and store it as kernel18.img on the SD card. Then the boot process will load the bare metal program instead of the Linux kernel image. Care must be taken to ensure that the linker prepares the program to run at address this and places the first executable instruction at the beginning of the image file. It is also important to make a copy of the original original kernel image so that it can be restored using another computer. If the original kernel is lost, then there will be no way to boot Linux until it is replaced. Okay, that makes sense. The boot process makes a little sense. A little, yes. So this is about Raspberry Pi, but in general, what happens is when I turn on my machine, then from a predetermined address, the CPU starts executing code, and that code, uh, l- first of all, the bootloader sets up some processor things, maybe like checking if the hardware that are connected to the computer are working perfectly or not, and then it branches off to the first instruction for the kernel, and from that point the kernel starts to spread and take control of the CPU and loads up the operating system. Write a bare metal program, I do not have anything to test it, and I really do not want to do this right now. Not like right now, but maybe at some point when I have an more interest in this. And using an interrupt, nah, I can use interrupts. Okay, different types of interrupts. I'm just cruising now the ARM processor profiles. That is okay. I will learn. I will see what it is. The ARM processor profiles. I guess only has been 30 minutes. Yep, only 30 minutes. And stream is working. I'm at the middle of the stream. Screen and a few frames have been dropped, which is fine. 57 frames have been dropped since its introduction in 1982 as the flagship processor for Acorn RISC machines ARM. The ARM processor has gone through many changes. The throughout the years, ARM processors have always maintained a good balance performance, and efficiency. Although originally intended as a desktop processor, the ARM architecture, even though it is efficient, but the it can have higher clock speeds than a CISC-based machine, but it can only execute simpler instructions and not complicated ones at once. The ARM architecture has been more successful than any other architecture for use in embedded applications. That is at least partially because of good choices made by its original designers. The architectural designs resulted in a processor that provides relatively high computing power with a relatively small number of transistors. The results and that results in relatively low power consumption. Yep. Today there are almost 20 major versions of ARM V7 architecture targeted for everything from small sensor to desktops and servers. And sales of ARM-based processors outnumber all other processor architectures combined. Historically, ARM has given numbers to various versions of the architecture. Yes, with the V7, they introduced a simpler scheme to describe different versions of the processor. They divided their processor families into three major profiles: A, A, R, M, ARM. Okay, the A version, A family, and applications processors are capable of running a full multi-user virtual memory multi-processing operating system. R family real-time processors are embedded are for embedded systems that may need powerful processor, cache, and or large amounts of memory. Powerful processors, cache, and large amount of memory for real-time works, and M for microcontrollers. Controller processors only execute thumb instructions and are intended for use in very small, cost sensitive embedded systems. They provide low cost, low power, and a small size, and many not have hardware floating points or other high performance features. Okay. ARM has three family of architectures: ARM, A, R, M, and M. Application, real time, and microcontroller, and I guess uh, for laptops and for PC, for mobiles, A family of processors is used. In 2014, when Russia invaded Crimea, ARM introduced the ARM V8 AArch64 architecture. This is the first radical change in the ARM architecture. Over 30 years, the new architecture extends the register set to 30 64-bit general purpose processors, general purpose registers, and has a completely new instruction set. Compatibility with V7 and earlier code is supported by switching the processor into 32-bit mode so that it executes the 32-bit ARM instruction set. And this is somewhat similar to the way the thumb instructions are supported on 32-bit core 32-bit ARM cores, but the change to 32-bit can be only be made when the processor is in privileged mode and drops back to unprivileged mode. Okay, okay, yeah. We can consider this book not done, but we have taken out of this book what we need. And now, 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 we will do one add-on of code problem in assembly. Let's see this one. It is going to be actually crazy. I don't know. The chief historian is always present for the big Christmas slide launch, but nobody has seen him in months. The last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figured that chief historian must be in one of the first 50 places they will look. So in order to save Christmas, you need to help them find 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. Two puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants one star. Good luck. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed some nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems planning to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Okay, throughout the chief historian's office, the historically significant locations are listed not by the name but by a unique number called the location ID. To make sure that they don't miss anything, the historians is split into two groups, each searching the office and trying to create their own complete list of location IDs. There is just one problem. By holding the two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, okay, we have two groups of people who are trying to make a list, and there are these are the lists that they have come up with. Maybe the lists are only off by a small amount. To find out, Pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, then second smallest number with the second smallest in the right, and so on. Within each pair, figure out how far apart the two numbers are. You will need to Within each pair, figure out how far apart the two numbers are. You will need to add up all those distances. For example, if you pair up 3 from list on the left and 7 from list on the right lists, the distance apart is 4. If you pair up 9 and 3, the distance is 6. So it would be 4 plus 6, 10. In the example listed above, to find the total distance between the lists left list and right list, and add up the distances between all of the pairs you found in the example above there. This is a total distance of 11. Your actual left and right lists contain many location IDs. What is the total distance between your list? This is the answer that I have inputted. Yep, I have done this problem earlier, but that was in JavaScript, which is a high level language, not in assembly. Let's see. You got this. You got this. Okay, let me do. Yesterday I was doing year 2015 in add-on of code using the C language. Now I will just git branch to 2024, no, git checkout to 2024, and git status. There are untracked files. Ls day 3. Okay, git add, and now git checkout 2024. I have to say committed. Can I not git stash saved working directory and index completed day 2? Yo, git status. Yep, already up to date. Then now I can just git checkout 2024. Yo, and n cd day 1 and n part1.s. No, part1.s. So I will be needing quite a few things. This is going to be in assembly. We split text.txt. Let me have this right here, and I will move this to the right. Shit, my bad. I will do one, move this to the right. That looks beautiful. Now, I don't know if I will be needing anything on the .data section. Yes, I will be needing strings to be printed on in the .data section. But yeah, shit. How do I even get it? I can get this file. Fucking hell, how do I read a file in assembly? I read a file using the C things, using a file pointer and stuff. But that is how I do it in C. How do I do it in this? How do I get even initialize a file pointer in assembly? File pointer is a data type which is inside of. I will have to understand what the file pointer contains, right? What it actually returns. Ah, fucking hell. How to read a file in ChatGPT. How to read a file in assembly. Reading a file in assembly depends on the operating system and Arch open, read, close. How to read a file in ARM64 assembly on Mac OS. I have to make a system call. Shit. System call. Okay, file name, flag, and mode. They will go like that. 0th register will contain the file name, first will contain the flag, and second will contain the mode. That way I can open the file and I will have a file descriptor in my X0 register. Okay, I will provide the buffer and the size that I want to read. Okay, that is the read syscall, and then I do not want to write. I will just close given the file descriptor. And now syscall for open in register number. Okay. I guess I got this. Um, how do I get the size of the file? That is the thing, right? When I do the second syscall, reading file into buffer. In the first one, I have to give this read 100 bytes max. Nah, I want to read how many bytes? Let's first of all try to read just 100 bytes. For that, first of all, I will store. Shit, I am getting auto suggestions. X30. That is crazy that I am getting auto suggestions in assembly. This is the first time that I am getting them. Yes, I have stored the frame register and the sync. I have stored the frame pointer and the link register. Now to call the first syscall open. In the 0th register, I will put in the name of the file. In the first, the flag, and in the third, in register number 2, the mode. Okay, and they will come from here, right? File name, which will be dot as keys text.txt, right? That is a file name. And mode is, I guess, 1 for reading a file, for opening a file, for ASCII, for opening a file in ASCII mode. And then mode, that is like I want to read or what. ASCIZ, ASCII's read. I think that might be correct. And I will get the ADRP get address, page address in the 0th register for file name and page, and add to it the file name, page offset. Right, I have the correct thing in here, and move into 0th first register 1. 1 means read the file in ASCII, I believe. I don't know, I will see. And then I will get the page address in register number 2 for move page, add into register 2, move page offset. Right, and now what is an invalid instruction? Add mode of ADRP. Oh, that is cool that I got an error. Now move into X16 the syscall number. The syscall number is this for open. Oh, error. Expected compatible register or local immediate. Mode at the rate page. Mode at the rate page. And that is fine. That is that is fine. Or maybe there is another level called mode. I don't know. Mode n. Nope. Error is still there, so that is fine. Modern. Right. As we see one and then return. Let's just see and compile this one. Blank part1 / out. Expected compatible register or local immediate. Compatible register or local immediate. Let me do then. Store it in the memory and get it at the time of the execution. Um, open n or open number. It will be stored in a double crazy, and the number will be this. Now at this point here I will get address in register 16 for open n its page address, and add to it x0, add to it the offset open n page of, and then load into the 16th register the value whose address is stored in the 16th register. Add to the 16th and this. Yeah, that is correct. Okay, that is seems to be wrong up there. An expected token? What the fuck do you mean by an expected token? Is this unexpected? Invalid floating point integer. Double means floating point. Okay. It's not double, I will say word. That should work. For architecture, AArch64 main referenced. Am I actually that stupid? Shit. I actually am that stupid. I didn't make a global thing called main, and I didn't even align at 2 bytes. Maybe I was too busy looking at the auto suggestions. Shit. Linker mode. Okay. At some point I typed mode. Here it is modern, and here it is mode. Okay. This has to be n modern not / out segmentation fault. Okay. At what point did I got the segmentation fault? I have file in this word this. Okay, let me use a full quad for this. That must be the reason for segmentation fault. Still, segmentation fault is still there. I'm getting the address of file name here, which has to be correct, and I'm getting the address for that in the second register, and then I'm getting the address and loading into the 16th register. the value that I put in the 17th uh, in the open number. This is called number for opening a file. But then what part is giving me the error? Let me see. Multiplying out. Okay, it is not this. One of this is giving me the error. Stack pointer, store pointer 29 and 30 onto the stack by giving it a pre-offset of 16, right, and then getting the page address of file name into the 0th register, moving 1 to 1, and then getting the page modern address into the second register, ADRP, to get the page address, and then add the modem offset. All of that is correct. As keys, yeah, as keys, yes. Open quad. Let me comment this and see if there is an error. Why is there? What the heck is causing that? At this point, there is literally nothing. Maybe I am reaching the end, but then at the end, I am not loading back this and the linker register. SP. So I have to load back the linker register, right? Of course. Yep, that was good. Now it is working. At least this much. One, two, three, four. One, two, three, four. One, two, three, four. One, two, three, four. Okay, so I can, I guess, safely say that I am getting, I am successfully being able to open a file. Now I need to load the file, and I have the file descriptor in the 0th address, 0th register. And what else do I need? I need buffer in the first register and size in register number 2. Buffer. Where can I get the buffer from? Well, I can make a buffer here in the .data section, or I can create a dynamic buffer in the heap by using calloc or by using malloc. Let's just say I will also be using a size thingy, and let me use EQU where, okay, what do I have to give first? This directive sets the value of a symbol to expression. Dot set, it is anonymous to dot set symbol and then expression. As symbol size would mean this expression 100 and this is 1000. Yeah, let's say 1000 error expected comma. Oh, there has to be a comma, I guess. uh, 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 where does the comma has to be? Where did you expected the comma? Oh, no way, that is good. Yes, now I have, let me just put it here, say, and do this at the top, and here I will just say buffer, which will be size space and size. Yes, I got a buffer of 1000 bytes. right? I have buffer. I have the file descriptor. I want the size. Size is also there. Now I can call it. And yes, also I will be needing uh, read number that will be stored in a quad. And what is the read number? Read number is the last one was 5. This is 3. Uh, Copy that, paste it here. This is 3. Right. I have in the 0th register the file descriptor. In the first register, I have to give the address for the buffer, for which I will get the page address in the register number 1 from for buffer, like that, page, and add to it the file buffer page offset. Okay, yes, I have the address in the first register for buffer. Now I want to put the size in the second register, like that. That is also good. Now I want to get the read number. For that, I will get the address in the 16th register. Address in the 16th register for read number. Get the page address for read number, and I will add to it the page offset read number page offset. It is hard to explain. It is hard to speak and also code at the same time. Well, currently it is, but if I keep doing it, I will get better and better and better and maybe better. Now load into the 16th register the value from the memory location whose address is in the 16th register. Can I call the syscall now? Yep, I guess I can. SVC1. Oh, I guess 1 here means exception level 1. Shit. Okay. Now at this point I should have in the buffer the values. I can call the printf function to print. Yes, I can call. Let's see if this much compiles and works. It does work. I don't know, I don't see the result, but it does work. So for printf, I will have to give in fmt, a format as keys, which will be print a string. Yep, that is it. Print a string, not a semicolon at the end. And then I also have to do should go to the last byte and put a null character there so that printf function ends. Right. Where do I have the address for buffer? It is lost. I have to get it back again. I can, well, store it on the stack. Let me get subtract from the stack pointer, get some, let's say 48 bytes. Now, not here, but here I got the buffer address. I will do store the contents of the first register onto the stack. Right. Right. Now I can load into the first register the address of the buffer. Yes, the address of the buffer. Now I have the address for the buffer. I need to go to its last byte. That is add to the address. Save to that. Size. If I add 1, if my size is 1, and if I add 1, I will get 1. So after adding size, I will do subtract from first register value. Let's say 1 would be good, but I don't want to risk it. 2. And now I will do, what is the character code for null? Hmm, I want to store byte, a single byte. So I will move into the second register, the character code for null. What is the character code for null? 0 for null. I guess it is 0, right? Yeah, it is 0. It is 0. So I can just move the 0th register, store a single byte from XZR to the address, to the memory location whose address is in this. Error, invalid operand for instruction. Shut up. Now the string is null terminated. I want to call the printf function. And I already have the address of the buffer onto the stack, and I just have to get the address for the format string in the 0th register. For that, I will first get the page address in the 0th register for format string, and then add to it bsm fmt page offset, right? Then just call the printf, and then add to the stack pointer what I took, give it back, etc. Okay, xzr wzr. I expect, why did it not print? I did call printf and I did not see any error, which is cool, which is cool, right? Which is cool. Let me also store a byte, uh, the character A at some point. So let me move in the second register the value 65, which stands for capital A, and store that byte from the second register onto the end of the buffer. Just x1 with an offset of -2, let's say. Like, okay, w, I have to do w. 42, w means only 32 bytes. Not slash out. Why don't I see anything? Why don't I see anything? What is the address that I'm giving to the stack pointer at this point? I stored the address onto the stack pointer. That is good. That is absolutely good. Onto the stack and then I got the address from the stack, and I'm just calling printf with the format string and stuff. Let me do. Oh, I do not have to provide the null character at the end, actually. Yep, because the format string itself has the null character. Let me just do this and expect it to work, and still it doesn't work. It should have, let me write, should be printed below this new line. Okay, it should be printed below this, but it was not. Percent %s, right? Percent %s does mean something. It means a string which is fucking null terminate. So I need to null terminate the string. Am I not null terminating the string? Let me switch this to character. Oh, I got equal to. Why is there an equal to there? Wait, is it just some random? No, it is not random. It is actually being read. But I do not have any equal to in the file that I'm trying to print. Before storing it to the stack, what if am I getting the correct address? Buffer, yes, it has a space size. Okay, and I'm getting the buffer address in one and then storing it onto the stack. Okay, before storing it to the stack, let me add to register one the value #1. Store it onto the stack and then subtract 1. Okay, I'm getting equal to and this mark for each character. Is the string not null terminated? Let me change this to, let's say, just char. Why? Because I can define it here. EQU char means at this point 2, not slash out, equal to next arrow and question mark, and that is what I'm getting every time. What if char is 3? When char is 3, I do not. When char is 3, I get question mark at the rate. What the fuck is being read into the file? I did call the SVC to read the file, and I did give it the file descriptor. Let's see what ChatGPT did. It moved the open syscall number in the 16th register, file name in the 0th address for the file name, pointer to the file name in the 0th register, and in the first register it has 0, and in the second register it has 0 mode. No need for read-only mode. And then make the syscall with number 0. Store the file descriptor. Okay. So a couple of things. I don't have to do modern thing here. I can, and here it has to be 0, and here also move into the second register 0. And yeah, replace this with this string. Ah shit. Slash out, not slash out. I am reading, bitch. It is printed below this, so that was the problem, it seems. Okay, now I have to increase just the number. Right, now I know how I can read a file in assembly. What do I do? It as 4,000. It is over a 4,000. Shit, how many lines are there in the puzzle input? Hmm. We split text.txt. There are 1,000 lines, so at least more than 10 characters in a line. I have to type in the number of characters for 1,000 lines. Mm, there are about 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 characters in each line for 1,000 lines. 13,000. Oh, oh. Clang / out. 41846 text.txt 41. Is there any 41846? 441848. That is not even goddamn close to the end. Let me do this. Make this 70,000. How about now? Ah, Clang / out. 41846. It seems to be getting stuck. 41846. That is what I got last time. Part1.s 70,000. Wait, what is the error? Error was with line 32. Move size. Expected compatible register or logical immediate. Is 70,000 too big? Shit. Is 70,000 really too big for it? File descriptor. Ah, shit. Okay. If that is the case, then let me see how to find out the length of a file. Yes, that is correct. Write to the standard output by putting the write syscall in here and moving 1 to 0, which means standard output. And in the first register, I have given the buffer, what I read. And in the 2th register, I gave the value of the 20th register, and 20th register has the store bytes read, the number of bytes that it read. So the read input gives me the number of bytes that it has read. That is also crazy. Okay, and I will call the syscall, close the file like that, and exit the program like that. Okay, how can I get this size for a file? Already fully charged. Okay, it seems to be thinking a lot. To get the size of a file in a file AArch64 assembly on Mac OS, you can use the fstat syscall. fstat this syscall. In the 0th register, I will put in the file descriptor, okay, and x1 the pointer to structure stat. Okay, is this holds the file size, st size, structure of stat. Mac OS में stat has this structure, and there is a value called st size within it, which contains the size of the file. This file size is at offset 48 bytes in the stat structure. Okay, I will have to give it a structure. I can just give it storage so that it will have the structure. Yeah, like this stat buff. It takes 144 bytes. Okay. Um, stat buff dot skip 144. Right. Right. Yeah. Right. I will not be reading the file. Expected assembly code. Why did you expect assembly code? I will not be reading the file here. And yes, after I have opened the file in these instructions, yes, I can just delete all of this. Now, at this point, I have the file descriptor in 0th register. Let me store it in the stack on the stack. No, not on the stack, but in a non-volatile register. That is register number 29, 19, or stack store here 19th and the 20th register onto the stack and give it an offset of I took 48 bytes. These will take up 16 bytes. So I can give it an offset of 32. Right, and move into the 19th register the file descriptor. Now I want to get the stat buffer address in register number 1. For that I will get the page address in register number 1 from stat buff page and then add to it the stat buff page offset right, right, and yes, also the call the syscall number for it, which is this f stat n. It will take up a quad, and let me do this, paste it. Yup. And yes, at this point I want to get the syscall number in register number 16. For that I will get first the page address in register number 16 for every stat n page. Now I will add to it the offset from that page and load into the 16th register the thing which is at the memory location whose address is in the 16th register, 16th goddamn register. And yep, I can increase the port rate if you guys like. Right, now that I have done that, wait, my phone's battery is just 58. That is not, that is okay. That will, no, not, wait. Yes, it is in memory storage. Yeah, it is okay. Yep. Screen is not stuck. I am visible and frames are not dropping much. That is cool. Now I have everything I wanted and I can call svc1 and also print. I would like to print fmt size dot as keys. It will contain cell size is %d, and what will this return? This will store this, and the size will be at an offset of 48 bytes from the base address for that. So let me also store the F state register's address in the 20th register. On this line, and later I can 48, right? So I want to get load into the first register, whatever is load. Wait, how much? 32 bits. 32 bits. Where is the load instruction? Size message now. Standard buff address is in this. Load file size into one. Load. Okay, it takes 32 bits, 64 bytes. Yes, I can see. I can see here, right here. Yes, it takes 64 bytes to store the whatever it is. X 0x30. I can give an offset like that. I have the file size in register number 1. Now I want to store it onto the stack. For that I will do store x30, the value in register number 1 on at the top of the stack. Now I have value, and now I need to get the format for size in register number 1. So I will first get the address in register number 0. God damn it, fuck. Format size page add to register number 0. The format it's offset, so that I have the address in register number 0 for the string, which is going to be the first input to the printf function, and I also have the at the top of the stack the second argument for the printf function, which is the size, and I can just call bl printf. Let's see. What is the error? F state referred fstat. F state n. It is F state n, not fstat. Where did I do F state? Yep, here. F state n. Okay, I expect to see size, which is just happens to be 0. Shit. Maybe because of the format that I'm trying to print it in. And let me do lx to print it in x. Okay, it is still 0, which is just sad. Am I getting the correct thing? Pointer to struct stat. It is like this. 32 bits for this. 32 means 4 plus 2 6 6 plus 2 8 plus 8 16 plus 4 20 plus 4 24 plus 4 28, and shit, what the heck is this? I don't know how much space this takes, but that is okay. I have to provide an offset of 48 bytes. That is x30. I did provide an offset of x30. I should have gotten what I wanted. I got the address for stack buff and put it in register number 1 and moved it to register number 20. Then I loaded the fstat syscall number in a register number 16 and then called the syscall, and then I loaded into register number 1 the value that should have been the value of the size, and then I stored it onto the stack. Then I got the address for print. I put it there. Well, before exiting, let me also get load pair the contents of register 19 and 20 from the stack, and there was an offset of 32 dot slash out. Why is the size 0? Why is the size 0? Text.txt. This should, this should, this should. Okay, this, I know this much part is correct because this worked in the past. The problem seems to be, yes, I have the file descriptor in register number 0, right? And then what am I doing? With the file descriptor in register number 0 and the address for stat buff in register number 1, and I stored the address for stat buff in register number 20, and then I got the fstat syscall number in register number 16, right? And then I called the syscall. After the syscall, I should have, what should I have? Actually, call the fstat to get the file size, make the call. Yes, after that, read the file size from the stat at an offset of x30. So I got the address in register number 0 like that. Oh, stat buff. Why is this like this? As if I'm load. Okay, this is used to get the address for a stat buff. Okay, I got the address of stat buff, and with an offset of 30, I got whatever is the value there into register number 1. Loaded file size in register number 1 and did the print thingy to print it. Then I closed the file and then I exited. 144. And I am also storing it on the stack. I'm storing the second argument onto the stack, like here. Store onto the stack this. Let me do move in x1 20. I should say size C size 20. Do I see 14 because I'm printing in hex. That is why I saw 14 in hex. 14 means 20 because 1, not 14. 1 4 means 20 because 1 means 16 and then 1 16 plus 4 is 20. So that is working. What if I try with different offsets? What if I got the value that is there with an offset of 0? What is the value there? There is the value, not the value 14. 14 is what I did. I wrote. It is not 14, it is 1 4. By the way, it seems to be goddamn empty at every place. What if I give it an offset of 1? Do I have to move up like that? No. Dot slash out and size is 0. Fucking hell. Well, I don't have to move with an offset of 1. I can move with an offset of 8, which makes more sense because most of the things are at 64-bit boundary. 48. Well, I can do right offset here and at the top I can do .equ offset and make it 16 here. Fucking hell. Let me go to the washroom for a little while and I'll be right back. So what we are trying to do here is read a text file in assembly, and that is all that we are trying to do. And how far have we come in that? Well, we can read file, but we have to find an automatic way through which we can get the end. We have to find an automatic way through which we can get the length of a file. How to get length of file in assembly AArch64. Assembly lseek, file name, file descriptor, register usage. Okay, open the file. That is called to open svc, move 0 into 1, 0 into register number 1, file okay, wait. Seek the end of the file. How do I seek the end of the file? Seek end. And I have the file descriptor in 0th register. Okay, seek end, seek end. Okay, what is the seek end is called? What is the seek end syscall, and how can I get the end? Wait, this is saying that to get the stat buff gets this. Ah, shit. How can I get the size for a file in Mac OS M1 assembly language AArch64? Bruh. Okay, fstat or lseek system call recommended. Last seek method one, which is the recommended method. It is fstat method. The syscall number is this. Okay, and I need to have the file descriptor in the 0th address. Do I have the file descriptor in the 0th register? And I need to have a pointer to the struct stat in register number 1, which I do have. Various metadata fields, and at some point I have the t file size thingy, which is stored at an offset of 30 from the start. Example, get file size using fstat. For which, first I open the file and I have the file descriptor in the 0th register, and I also store it into the 19th register. Then I am getting the file descriptor here after the syscall. Wait. And no, yeah. And I'm moving F stat in here in the 16th register, and this and this. What do I do? This is called 0. If that makes any change. What is the error in here? Oh, there has to be a comma. No 40. Change the offset to it was supposed to be 30348. 48. I should definitely get the size of the file. But why the fuck is it 0? Yes. I thought I'm so stupid. No, I'm not. Well, I am, but I thought that I was not loading the value correctly. But, well, I am not loading the value correctly. Let me do this. Let me just print the address. What now? Uh, 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 uh. I should get the address printed. Yes, I am getting the address. But I do not want to get the address. I want to get the value, actual value at that address, for which I have to do load register number 1 with whatever is at the address which is stored in register number 21, and it is just happens to be 0. Fucking hell. This is the recommended method, which is just not working. Load file size into register number 1. I am doing this correctly, right? For fstat, this has to be this is call number is correct, right? To call fstat, this is call number is correct, and I'm getting that in register number 29 16. Yes, I'm getting that in register number 29, and in register number X I'm getting the file descriptor. I'm not, but I just put it there, right? And is this the place that I got the file descriptor? Yes, this is all correct. And let me even close the file at the end. Like close number is quad x0. What is the number for close? Close is 1 at the end. 2 1. So after this, and to do close, I just need the exit code. No, I need the file descriptor. Oh, close is 6. Close is 6. And to close a file, I need to get its move into register number 0, the file descriptor, and in register number 6, I will get the close syscall number. For that, I will first get the close number page offset, not page offset, but the address of the page itself, page address, and then I will add to it the offset. Right? Is that correct? Yes. Then I can just call svc 0. The file should be closed at this point if I didn't mess up at this point. at any point, and seems like I did mess up in here. This is close in, not just close. Okay, so I am there is something segmentation fault because of this, because of this, because of this. Mhm, mhm. Is it because of this? Let me comment it out. And do I still get the segmentation called fault? Nope, it is because of that. Why is this thing causing a segmentation fault? Oh, because I have to get the value. Load register number 16 with the value which is stored at the memory location whose address is in register number 16. Not slash out. Yes, I am closing the file like a good person, but it is still not working. Let me use fseek, the second method. Link it, yes, into this and echo. Yeah, method 2 lseek alternative, lseek file descriptor, offset x2 wins. Okay. After reading the file, seek the end of the file to get the size. In the 0th address, I will put in the file descriptor. Okay, and offset 0 for seeking and 2 for end seek. And then call this syscall and store the file size in. This will give me the file size itself. I do not need fstat or anything for that. Okay, let's try to do that instead. I can comment all of this out. And what do I need? I need x0, the file descriptor in register number 0, and in register number 1 I need to put in 0, which is the offset for seeking 0. Okay, 0, and in register number 2 I will put in 2, and 2 means seek the end of the file. And now the syscall number in register number 16, and the syscall number I will have to store it there. Seek n dot quad. What is the syscall number for seek? Syscall number for seek is this. Yup, 38. Now I will move. First, get into the 16th register. Seek n page address and add to it seek n page offset. And I hope my stream is not getting stuck. Yes, seems like it is not. And svc system call 0. So after that I should have the in the 0th address, in the 0th register I should have the size of the file, for which I'll move it up to the stack like that. Dot slash out. Invalid syscall. This is invalid syscall. How? Oh yes, of course. Load register number 16 with the X address is that and that. Dot slash out. E. 14. That is not the size of the file. 14 is not size of the file. No, no. That is not correct. That is simply not correct. Let me do um a digit here instead of large hexadecimal value. 14. Wait, why am I getting 14? As if I was storing the value 14 myself there. After making this syscall, I should have in the 0th register the size, right? Correct. In the 0th register, I have the file descriptor. Do I have it? Yes, I have it in the 0th register. In the first register, I have the offset 0. Do I have it? I have it. And in the second register, I have the value 2, which means seek the end of the file. And then I make the syscall. Well, of course, getting the syscall number in the 16th register. And I get the file size in the 20th register. Which method should you use? fstat is faster and recommended. Simpler, just moves the file pointer. What do you mean moves the file pointer? Wait, fc, I have this here, and store size of file in 20th register. Okay. Alters file offset may require seeking back. Okay, I would have to do rewind. Okay. How can I read file with branching of 2, 3 functions? Read a file in ARM. fopen, fread, fclose. Okay, this is what I'm going to do. Yes, this is what I'm going to do. I'm going to read with the help of, I'm going to delete all of this, like all of it, that much, and store pair the 19 and the 20th register onto the stack with an offset of 32, and then load them at the end. Now I want to call fopen function, which is fopen, which what are the arguments for fopen? Fopen take yeah, right. File name and read mode. Okay, so I need to do something like this text.txt and r for read. Okay, in the 0th register I will have that ADRP get the address in the 0th register for file name, which is that. Remove all of that shit. Remove even this. Get that back at least. Format size. Yeah, yes. File name. Yes. File name, page address, and then add to it file name, page offset. I have the right thing in the 0th register. Now I will get address in the first register for read mode, which is as keys are right. So as keys are read mode at the rate page and add to x1 read mode page offset. I have everything that I wanted. Now I can just branch link to f open. Is that correct? And I should have in the 0th register the pointer, a file pointer, a pointer to a file. What do I want to do with that? I want to do f read, but before that I want to get the end of the file, the size of the file. Okay, so in this function I will just get the size of that file. So after doing this, let me move into 19th register the file pointer, and now what do I want? I want to get the end of the file. For that I will first have to seek end f seek with file pointer as the first argument and 1 as the 0 as the second, and seek end as the third argument. Right, and seek end simply means 0. No, seek end simply means 2. Right, I'm just going to blindfoldedly make the things. Move into the 0th register the address which I already had in there, but anyways, in the first register get move 0 and move into the second register number 2, that is 2, and then branch link to f seek. Right, now I should have nothing. The pointer in the file should have moved to the end of the file. Now I want to get length, for which is f tell file pointer, and what are the other arguments for file pointer? Let me see in my C code. Code branch get checkout 2020 2015 series day 1, let's say, and part 1.s. It is, hey, what the heck? Oh no, oh, part 1.c. Yes, ftl. Okay, I only have to give the pointer to the file. Yes, that is all I need to ftl. Yes, that is all I should practically need. So move into the 0th register the file pointer and simply branch link to ftl. Now I should have the length in register number 0, so I will move it in register number 20 from register number 0. Now I want to print it, print length. For printing the length, I want in the page address in register number 0 for fmt size page and add to it fmt size page offset, right? And in at the top of the stack I need the argument that is to be given to printf as the second argument for printf. For that I will do is store the content of the 20th register, which is the size at the top of the stack and just branch link to printf, and yeah, I should be a happy man now. Okay, no errors, and I got the size 7000. Is that actually the size? Is that the correct size? Nah, that does not seem like the correct size for the file. Okay, anyways, let's, after printing the link, I want to see rewind. That just needs the file pointer, right? Yep, only the file pointer. So move into x20, move into 20 the value of x19, which is the file pointer, and branch link rewind, right? Well, if I am using C library functions, is it actually assembly language that I'm coding in, or just a harder way to code in C? I guess this is just a harder way to code in C. After getting that, I have to malloc a buffer. Right. What does the malloc function require? Length, which is in register number 20. Malloc, of course, malloc requires length. I will do length plus 1 if that makes you happy. Now, move into register number 0, the length from register number 2, and increase that by 1. Okay, and branch link to malloc. Now I have the buffer pointer in register 0, and I need to use some more non-volatile registers. So I will store register number 21 and 22 also at the stack with an offset of 16. Right, and here I will do f read malloc and move x0, move into register number 21 the value of 0th register, that is the buffer pointer. Now fread, what does fread require? Well, buffer pointer in the first as the first argument, then number 1 as the second, and length, and then the file pointer. 1 length file pointer. Okay, I need to have buffer pointer in register number 0. So move into register 0. Buffer pointer is in register number 21. Move into register 1, the value 1, and move into x2, the length, and length is in register number 20, and move into register number 3, the file pointer, which is in register number 19. That should do it, and then just branch link to fread. That should do it, and then print buffer. Now I should have read the buffer. Now I want to print the buffer. I can just give in the buffer directly. I can give in the buffer directly without anything else. So move into the 0th register the address for the buffer, which is in register number 21, and branch link to printf. And now I should see a lot of errors, I suppose. Yeah, LDP load pair 21st and 22th register from stack pointer with an offset of 16. I should see errors. What the heck? Yeah, but this is like, you know, uh, I am using C library functions and not making the syscalls on my own. So that doesn't count as a great accomplishment. But now that I can do that much at least, I can switch this to making syscalls. And I guess I will be streaming assembly tomorrow also to complete this question. Wait, why? In which folder am I? I'm in 2015 part. Okay, so I want to go into part. How did this happen? When did I got back into the 2015? Huh, after this I got back here. Okay, git, not commit, but git. What? Git checkout 2024 ls n part 1.s. Yeah, part 1.s. Yes, it has the latest code and git dot slash run. Okay, that runs correctly. Write the cat text.txt. Yes. So I can read the file at least and print the file. Now there are two options. Either I can change this whole logic to system calls, which I will. But first, do I want to change this to system calls, or first do I want to solve the actual question? I guess first I will solve the actual question and then shift this all to system calls. Now I will be shit. I just got the contents of the file and nothing else. Fucking hell. We split text.txt and move this to the right a bit like that. So are numbers of same length? It seems they are of same length. And they have a persistent space, 3 spaces in between. Okay. And 1, 2, 3, 4, 5. 5 characters, then 3 spaces, and then 5 numbers, then 3 spaces, and then 5 numbers. Now, what do I want to do? I want to change this number and fucking hell. I want shit. I want fuck. Yes. I will go line by line and I will create fuck. Let me create 2 arrays on the stack in the data section. Ar1, Ar1, which will skip, which will have how many bytes? 1,000. This is the number of bytes, right? And 5,000. Let's just say 6. No. Yeah. Skips over 1 byte, right? So, and how many bytes do I need? I have 1,000 rows, and each row has 2 digits, 2 numbers of 5 digit long. And 1 digit will go in 1 byte? Nah. no, 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 no. One digit will not go in 1 byte. I will be storing them in 32-byte pair. So 4,000 seems good. Yeah, 4,000. And array 2 is also of 4,000 byte long. That means 4. That means 1,032-bit numbers can be stored in this, right? And then at the end, after getting my buffer filled, I want to first of all fill up the arrays and then consistently keep finding. Yeah, first of all, I'll just fill up the array. Fill the arrays. Uh, how do I fill the arrays? That is what I have. I will have to go line by line. Right. Let me move a counter in register number 0, which will start at 0 and go up till 1,000. And I know for a fact that the first 5 bytes are going to store the number. How can I change that 5 byte into a number? I can. Can't I? I can. Can I not do that? It is in memory. Yeah. Uh, okay. Compare x0 with 1,000 and no. This is. I will call this loop, and this will have. I thought this might be easy, but at the end I will add to the 0th register one, that is incremented, and compare it with 0 or xzr, and branch if less than, if 0th register is less than, not 0, but I have to compare it with 1,000, and if 0 is less, if the content of the, if the counter is less than 1,000, then I will branch back to the loop. No, 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 no. So I G the offset is in the 0th register, and I want to get the numbers, and the base address for the buffer is in register number 21. So okay, let me move into register number 1, the base address for the buffer. Now I need to add to it some offset. Add to x21 the value 1, logical shift left. Can I do that? No, I don't think so. Let's just do it. Not 1. Add to it the contents of the 0th register with a logical shift left. Logical shift left of 5 plus 5 plus 3, 13. I have to multiply the contents of register number 0 with 13 and fucking hell, multiply them somewhere else. And the 0, multiply them by 13. I cannot multiply by an immediate value, can I not? I can, I guess I can multiply by an immediate value. 13, multiply this by 13 and the and okay, now the 21 register should have the base address for the line that I am at, for the row that I am at. So starting from that point, a character, the number is 5 digits long. The whole line is 5 plus 5, 10 plus 3 for spaces, 13 lines long, and there is also the new line character at the end. So it has to be 14. Yes, and after that, after getting the base address for the row that I am at, I want to get these characters. How do I get that? Get them. A register is 8 bytes long. 8 bytes long, but this is 15 bytes long, 14 bytes long. I only need 10 bytes, specific, very specific 10 bytes from them. So I can load in, let's say, register number 3, whatever is register number 1's value. So I will have the first 5 and then the 3 spaces from that, and load into register number 4 this with an offset of 5. Yes, with an offset, or maybe an offset of 8, so that I have 5 numbers and some 3 new things. Right, right. And then I can just logically shift right the third register and save it into the third register how many times? 3 times. And logically shift right the fourth x4, save into x4 by 3. I should have the characters in the third and the fourth register that I want, and now I want to convert them from characters to numbers. How do I convert them from characters to numbers? They are stored in ASCII format. How do I convert from characters to numbers? I can do it pretty easily in C, but this is assembly. Uh, a string of characters to numbers. I know what is the ASCII code for 0. ASCII codes. Yes, what is the ASCII code for 0? It is 30 in hex. Okay, 30. That is what I want. That is what I can subtract. But I need to work with individual byte from these registers. Okay, to get 1 byte, what do I do? To get 1 byte, I will take its AND. Fucking hell. So I can make a loop for it. to loop over every character, or I can do this manually. Let me first do it manually. So I will take the AND of the third register. No, take the and store it in the fifth register. The AND for third register with the value FF. That is in hexadecimal FF. This should give me the last byte. Yes, for the first number, right? And now I want the last byte. Oh shit! Oh yes, this will give me the last byte, but I should start with getting the first byte so that I can multiply it by 10 and then add the new number. Okay, for that I have to do 0 0 0 0 2 3 4, which is going to be too big to be able to store here. So what can I do after getting the last byte? Yes, nah, no shit, no, I got this, I got this, I got this. I got the last byte, and I need to convert that character from ASCII to number. For that, I will subtract from x5 and store into x5 the hexadecimal value 30, which is 48. Right now, in the fifth register, I have the LSB, and the lowest digit in the number. I'm just babbling at this point, but I think I'm getting ahead. I am actually making progress. Now I have that. So in which register will I be storing the actual answer, the actual numbers? I guess I have already used third and fourth. I will be using fifth and sixth for getting the bytes. So I guess I will be using the seventh register. So move x5 into x, move into x7 the value of x5. Right, so I have at least one digit in x7. Now let me divide this into parts. Getting first number. Right, I have that. Now after getting one digit, I will get the next. How will I get the next digit? By logical shift right x3 by 1 and ending. Shit, I guess I got it. x0 xff and subtract from x5 x5 x0 x30. That is just copy and paste. Nope, that is not. Now I need to multiply x7 x7 and store into x7 by 10. Right, no, no, not x7 but x5 x5 and add to x7 and store into x7 the contents of x5. Now I should have two values. I have to copy, do this same thing couple of times and 5 times to be exact. After getting this, I will right shift it again and take the last byte, subtract 0 from it to get the number, multiply the number by not by 10. First time I will multiply, I will just move it right like that. The next time I will multiply it by 10, next time by 100, next time by 1000, and this might just be getting too big for it to store. 4. I have the number, the first number. Hooray! copy this. I want to get now the second number, for which I will be using x6, 6, instead of 7, 8, 3 becomes 4, 5 becomes 6. Well, let me first see if I am getting the first number or not. Yes, after doing this, I should have the first number in here. Then I will just, shit, I do not want to blow this all off, and call printf. How do I see the first number? I will have to call printf. I will have to call printf, but that would blow up everything that I have done here. I can store them onto the stack. That seems to be the thing to do. Store them onto the stack. So I will subtract from the stack some space, 7 into 8, 7, 8, 56, but no, 56 does not seem like a good number. 8, 8 is 64, yeah, 64 bytes. I will start storing from stp store x0 and x1 just blindly. I will just keep doing this with an offset of not 64 but 64 minus 856, and store pair now x2 and x3 onto the stack with the 56, 40, 48, and store pair x4 and x5 onto the stack with an offset of 48, 40. Offset is getting smaller and smaller, and x6, and store pair x6 and x7 onto the stack, and I am stupid. This has to reduce by 16. So this becomes 40 and 16, this becomes 32, and this becomes 16. Right. Now I want to call printf. For that, I will give in a format string fmt number. It will be called as keys number %d new line. What the heck is wrong? Too few operands for instructions. This is not an instruction, you dumbass. And yep, in the 0th register, I will get the page address ADRP in x0 from fmt num, right? Num is the page address, and add to it, add to the 0th register fmt num page offset, right? After adding the page offset, what do I need? I need to store the number onto the stack. And by luck, I do have some space on the stack. str store, which register has the value? 7th register. Store it on the top of the stack, and then just call printf. Yes, call printf, and ldp, load everything back, x0 and x1 sp with an offset of 56. Alright, and ldp x2 and x3, x3 with an offset of x40 from the stack, ldp x4 and x5 with an offset of x32, and ldp x6, x7 from the stack, SP with an offset of 16. Right, and into the SP 64. This should do it. This should do it. This should do it. Yep, this should, I guess. And now error. Oh, fucking hell. I guess they are solvable. Okay, that one I expected to see the first one. Okay, I will just solve them one by one. What line was it? Where was there? In line number 71 and part line number 71. Okay, I cannot multiply directly with an immediate value. I have to store that value at some place. But at what place? I got the base address in 1. Okay, and so the fuck? Why am I adding to the base address itself? That is stupid. I have to use a copy of it. Yes. Okay, I will use the first register for that. Move into x1 14, and here I will use x1, and then yeah, at least one error should be solved. Yes, one is solved. Now add this line 73. Too few arguments for add. That one, line 73. Yes, what am I trying to add here? Yes, add. Here comes x1. Right, and multiply again, and again a few times at around line 85. And part 1, line 85. Here I cannot multiply with an immediate value. So for that I will move into x1. Let's say 10 on this 10, the value itself, and here when I'm multiplying I can do this by x1 and x2. Move x2, move 10 into x2. Okay, I will multiply here by x1, and the next time that I am multiplying I have to multiply by 10, so I will multiply and store into x1 by multiplying by x2, and here I will multiply by the contents of x1, right, and then the next time here, so which will be equal to multiply x1 by the contents of x2, and here use x1 to multiply, and the same. Why am I multiplying this by 10? This is 10,000. This should be 1,000. That should be 100. And wait, here 1. Here I'm multiplying by 10. Here I am multiplying by 100. Here I am multiplying by 1,000. Here 10,000. Here it has 4 zeros. And 4 zeros is correct. But what The fuck? Am I trying to get more values than there are? Wait, wait, wait. I got the last bit. I have 5 characters. I got the last bit here. I subtracted the ASCII value for 0 to get the value, and I moved that value to the register on number 7. That is good. And then I left shifted register number 3. Register number 3, it has to be right shift. It has to be a right shift. Yes, right shifted register number 3. Then I got the last byte in register number 5. Yes, and then I subtracted the ASCII code for 0. Then I multiplied that by 10. I got the second digit from the last for a number, and then I right shifted. Oh, 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 oh. It is logical shift R LSR, so it is correct. Right shift it once and get the value again. Let's get the value again by right shifting it once. Right, and subtract and multiply and add. So I have 3 numbers at this point, and then I right shift it again, get the last byte, get the value of the digit, multiply and add. Now I have 4 numbers. Right, I have 4 numbers. Then I right shift it again, get the last value, do this and multiply and add. So I have all the numbers. I was doing it for one extra time. And subtract and store and print line number 170, 127, 127. This, what am I trying to do here? Oh, x0. Okay. I expect to see a list of numbers. Motherfucker. Is it wrong? It is wrong. But I got something. Fucking. Okay. Okay, we will continue this tomorrow. Right? Nah. What is getting the fuck is wronging in here? Or is there something wrong? Cat this, the last value here is 856280, and it is nowhere to be seen in here. Part1.s, what the heck is part1.s? Yep, yes. So instead of printing the whole thing, let me print just the last digit. Yeah. And see if that works. No, that does not work. Why does it not work? Let me do number instead of number. Let me do character. Oh, it depends on if it is big endian or a small endian. If it is character that I am printing. Seventh register has the value that is inside the fifth register. And what does the fifth register has? Fifth register has the last bit from this after subtracting 30 from it. clearly messing up some at some point. So, so. Let me not do this part and go to the top and change the D to a character, and let's see if I am getting the last character, which I'm not. And let me go to the washroom for a minute, and I will be back and we will see this further. I'm not getting the last character from the numbers. So what the fuck am I getting? How do I see what I am getting? Character. Maybe the way that I am storing. Yes, let me just store a byte here. It is still wrong. So it is, what is it? LSB goes to the last place. Uh, small Indian storage thing. Small Indian. Right. Wrong. Is am I even getting the string that I want? Let me, instead of doing all of this, let me just not give this to this, but which register has the base address. The base address was calculated by this part. Let me do. Comment this out. Comment this out. Comment this out. Comment everything out. And so now the first register has the base offset where I want to work with. So I will, instead of getting this, I will move to register number 0 the value in register number 1. And what am I hoping to see by this? I am hoping to see if I am successfully able to individually get every row. Yes, it seems so. Okay, and let me do a put char Put char takes in a character. What is the character value for new line? ASCII value for new line. ASCII new line. Uh, 10. Okay. After doing that, I'll make a move into x0, 10, and branch to put char. Right. Yes, 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 yeah. So yes, I am successfully able to get the rows. I got the last one when the index was this. I got last two when the index was last 3, 4, 5. Yes. Okay, so that is good. No problem in that part. Let me eat a little something. Shit. Hmm. So I can successfully get the um, strings and stuff. Each row, I am able to get successfully each row, right? And now I want to get every number from each row. Okay, right. How do I get the numbers? I'm loading the address, the first 8 bytes of every row into first 8 bytes of every row into register number 3, and then I am loading the next 8 bytes into register number 4. Okay, that makes sense. And among those 8 bytes, the first 5 in both the cases represent the numbers that I want to print, right? Yes. But do they represent the numbers? How do I check if they represent the numbers or not? How do I check? Yes, I can call put char. Yes, let me do this. And I will call put char on both of these instead of calling printf here like a stupid person. Right. Yeah. Move to x0, the value from x3, and then branch link put char and move x0 and the value from x4 and branch link put char. Am I getting something? I get 1 4 1 4 cat. Yes, that is correct. 1 and 4, that is what I should get. And if I right shift them, what will I get? Okay, that is okay. And now if I, before calling the put char, if I logically shift left Yeah, logically shift left the contents of x0 by 1 and do the same. Ah, shit. Do the same thing for this. Will I get? I should see 9, 6 for the last number. It is BH. Okay, I'm getting totally random things now. BH. Logically shifting left. Oh, okay, 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 okay. Shift left by 8. What did I say? I should see 9, 6. Am I seeing the last bit? Ah, fucking hell, yes. Yes, 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 yes. Logically shift right. Yes, of course, logically shift right. Shit, it makes sense. I should see 9, 6 at the end. Fucking, fucking. Okay, now it seems like it should work. If I just change this to 8 instead of 1. Yes, change this to 8. Change this to 8. This to 8. Yeah, and now unmute it. Got the base address in here, and in the 7th register, I should have the value. Wait. Mm, okay. Mm, we are getting something, but that something does not seem to be right. How am I getting that something? I'm getting that something after storing to the stack the contents of register number 7. Yeah. Hmm, hex hex to not ASCII, hex to um decimal and two's complement, online two's complement calculator. This is the number. In decimal it is, wait, what two's complement, yes. No, not the two's complement. Unsigned. Nope, it is signed. Gave this, right? And they are saying, oh, it does not take 64-bit values. It is just taking that, but that should also give me the correct answer. But it is not. Wait, if all of the starting ones are F, that means then that the value is negative, but it is not negative. I think I should come back to it tomorrow. And tomorrow we will hopefully do this just a shy of 3 hours. That is okay. Bye.